Thanks a lot, Paul. Thank you very much for your attendance this afternoon. I look forward to spending the next 15 minutes or so talking about machine learning in the context of augmented reality. A little bit about me. So I'm the Chief Strategy Officer of Contextere. What we're building is an intelligent personal agent for field-based workers. And the idea is to take individual context in the field and look at using machine learning as well as intelligent context curation algorithms, figure out exactly what's necessary to guide that user and to let them know now what. What do I need to do now? What do I need to understand now? Where do I need to go now? Right? So that now what, that intelligent context is obviously delivered in a variety of ways, and there are a variety of ways we can augment the human with that information. And I'll get into that as we go forward here. So let's look at the industrial landscape of machine learning for a second. Basically, you can, in this kind of standard 2x2 matrix approach, you can divide machine learning into things that are machine-centric and things that are human-centric. And on the other hand, things that are on the edge, on the industrial internet edge, and things are in the center of an organization. If you look at that 2x2 matrix, in the bottom left, there's a lot of effort that's put into automated planning, and using machine learning and data science to figure out what to do for planning around OPEX expenses, CAPEX expenses, operational efficiency, that type of thing. There's a lot of work being done on the top left, with making machines smarter, more machine learning on the edge for machines so they can optimize and self-optimize and improve their efficiency. And there's a lot of work in the bottom right-hand corner looking at optimizing larger teams across organizations in terms of operational efficiencies and workflow optimization. What we find, though, is there's not a lot of effort that's put in the top right corner, which is really focused at the human, the individual human that's out in the field trying to do a job today, trying to understand what they need to get that job done and what they need to be able to do it most efficiently and effectively and correctly. Right? So who are those humans at the edge? They are the men and women that are out in the field working with remote assets every day, whether that's on the flight line or in a remote oil patch or in other environments where they're looking for the right information at the right time to try to get that job done, to operate, to troubleshoot, and to maintain complex equipment. Those are the humans that we're focused on in this discussion, trying to enable those humans with the benefits of machine learning that's often just restricted back into the enterprise, in the core of the enterprise. So why is machine learning critical? First off, one of the main issues here is that true ROI is really captured in what we call in the military context the last tactical mile. Getting that information to the person at the edge that needs to make a decision and needs to make a decision fast or increase their productivity. But let's look at the numbers across here. I won't go into them all, but the bottom line is we have a need for 1 billion new skilled workers before 2030. How are they going to be skilled? How are they going to be trained? How are they going to be enabled in the field? 1 billion people in new jobs with the skills to do the jobs right. All right? We need a lot of new people, but if you look at the rest of the information on here, we also need them to be more productive, more efficient, decrease their error rates, and be more safe. That's a tall order. That's one of the areas that we see machine learning really driving this process, enabling new workers and skilled workers in the field to know better what to do using the history of the organization, the history of their experience, and the history of the machines that they're working on, giving them the smart guidance on whatever device they're using to be able to operate most effectively. As we all know here, AR, a fundamental element of AR is context, right? Understanding where the human is and what they're nearby, and then delivering them in the appropriate information. Particularly true in an industrial context. What machines are they nearby? What environment are they in? But if you look at context, There's a lot of elements of context. It's not just about where they are and what equipment they're by. There's also how are they feeling? What's their physiology today? What's the weather like? What is what's the state of the equipment that they're nearby? What role do they play? All of those things define and create context for that user in the field. We don't currently use all of that in most AR systems, but if you really look at smart context, we need to consider all of those elements because each is relevant to the user in the job that they're doing at that moment. Okay? But context is continuously changing. I perform differently today than I did yesterday. The equipment is operating differently today than it did last week. The organizational objectives are different this year than they were last year. But most of our approaches to AR and guidance delivery comes from the standard mode, which is our historical model of training and manuals, where we deliver the same guidance day over day, regardless of who I am, what my conditions are, and what might have changed for me. So how do we make the guidance more smart? How do we add more smart context into that process? To make sure that the information that is delivered to that user constantly evolves, so it's the right information at the right time, truly the right information at the right time. And that's really where machine learning comes in for that human at the edge. Machine learning provides an adaptive, evolving environment based on the history of shared data and knowledge to be able to change the way that information is presented to the user. So let's look at the machine learning strategies. So machine learning is very much a continuum of algorithmic choices, right? And it's across, on the left side here, a whole range of application areas that range from just understanding how to be up 24/7 to predictive analytics that's applied to predictive maintenance solutions and maintenance operations, and then deeper into that background of data mining algorithms, and then moving through to machine learning and more complex AI. Right? So you've got this continuum, and if anybody's delved into the issues of machine learning, it's not easy, right? So if you look at it, there's actually many, many different algorithmic choices, all for different optimization solutions. So what type of data do I have? How frequently is the data coming in? Do I know what problem I'm trying to solve? All of those questions can affect your choices around algorithms, and that's not an easy nut to crack. Okay. There are many algorithms, and as Pedro Domingo said in his book, there is no master algorithm. Well, there's the holy grail of trying to find a master algorithm, and data scientists and other learners of various types are working towards that to find out, is there a master algorithm that can be the kind of the one ring that controls them all, so to speak. We don't have that right now. Instead, we've got a whole hierarchy of algorithms in various spaces. Unsupervised learning algorithms, supervised learning algorithms, the combination of those into semi-supervised learning algorithms. And you can see on the right side some kind of key criteria around that. Unsupervised algorithms are particularly appropriate where data is unlabeled. We don't know what problem we're trying to solve, and the algorithms need to evolve and learn by themselves and come up with clustering solutions and regression solutions that allow it to learn as it goes, so to speak. Supervised learning algorithms are great for when you know what question you're asking. And very importantly, you have a large base of data to be able to work from and with, to be able to run learners against, to be able to choose and validate whether those algorithms are the appropriate ones. As it says, semi-supervised is really kind of the combination of the two, right? So some things we know, some things we don't. Injection of the oversight of a data scientist or a human into that process to try to optimize the learning systems. And then reinforcement learning along the bottom is really, it's basically a feedback loop of learning approaches, right? So the outcomes of learners feed back into other learners to evolve the process, and they can be used, with unsupervised or supervised learning. In the center there, which is a little bit of it's the eye chart picture, but I think these are online or will be online. And if anybody wants them, I can send them out later if you want to see what it actually says. But there's algorithms in each of those buckets to choose from, optimized for your particular needs, right? And the challenge here is that machine learning for augmented reality is hard. Machine learning in its best case is hard, but applied to augmented reality, where the individual's evolving, we don't have the data sets of individual historical performance in many cases, and we're just evolving enterprise data information in various ways to try to figure out what we're tapping into. So applying machine learning in this context is going to be particularly challenging. In general, what we're seeing is that data is emergent in the AR context. My performance as an end user in the field changes over time. That knowledge is very much, that data associated with my performance is very much emergent. Data associated with equipment history is starting to grow. The folks like GE with the Predix engines and other things like that are growing a large history of data to support their predictive maintenance solutions. And case-based reasoning systems are coming along in very effective ways to support troubleshooting pieces. But each of those are individual pockets of data that aren't connected right now and need to find ways to connect them. Okay? So data is emergent in many cases. And as a result, it's also, another characteristic of a lot of the data in the AR space is it's unlabeled. We don't have a concrete criteria for it. It's not nicely clustered together. We don't have groups of performance in various ways that we can say, okay, this type of person gets this information all the time. If we're looking at it from a optimization point of view, we need to understand more of that. So those clusters and that analysis needs to emerge over time more effectively using the algorithms that we choose. So in general, the recommended approach for us is really, in most of the algorithmic choices, is you're using a combination. There isn't one that you're using and only using one to solve all problems. It's a combination of different learners that feed into each other and support the evolution of the algorithms. But in general, because of that emergent and unlabeled nature of a lot of the AR data, unsupervised learning techniques are the primary focus that organizations like ourselves and others are focused on to be able to build the algorithms and define the algorithms over time. But let's not lose sight of what this is really about, right? This is ultimately about the end goal of machine learning, which is actionable data at the point of service. So this isn't about nice algorithms and elegant software. This is about making sure that the data that's delivered to a user in the field is actionable at every moment in time based on their evolving context, right? So that combination of smart and curation of back-end data, enterprise information, as well as live data off of sensors that may be relevant to me because of where I am, combined with the machine learning algorithms to make sure the right stuff is put together in the right way and delivered to me so I can know what's most important at that moment in time. The ultimate goal in this, again, is to make sure that human in the field is more capable, more safe, more efficient in what they're doing in their job. And ultimately, for that to happen, that human in the field also needs to trust the system and the information that's being delivered to them every moment in time. If the system gets it wrong, if the algorithms get it wrong, then the infrastructure, the ICT infrastructure that's supporting that human in the field it becomes unreliable and untrustworthy. So making sure that you put the time into the machine learning algorithms and the processes associated with that and understand what data is important and what data is not important and relevant at each moment in time is particularly critical, because ultimately that human at the edge needs to trust that what they're receiving at every moment in time is exactly the right guidance. Not maybe the right guidance, but exactly the right guidance, right? And they need to trust that they're going to get that guidance either when or before they need it, and to do that in a very reliable way. Okay? So I mean, machine learning in general is an evolving space. There's been a lot of effort into it and various approaches to cognitive learning systems, deep learning systems, and others. But certainly when you look at how it can be applied, the potential for it to be applied to optimize the experiences, to create smart context for end users in the field, and smart data and smart guidance on AR and various other forms of augmentations for the human in the field. It's a key area that's ripe for investment and ripe for investigation. Okay. Thank you very much.